part of my routine. I feel like I'm doing stand-up now. It's a part of me. But anyway, so here we are, Monday, back in school. Don't know why. The Cali score, I don't know if you guys saw the updated Cali score. We're at 3.3 right now. 3. So it went up. Yeah, the fourth category, as I predicted, the percent positivity rate went up over the threshold of 10%, thus it went to a 3. So we're at a 4, 3, 3. If one of those 3s becomes a 4, we're shut down virtually. But it won't happen. It won't happen for a lot of different reasons. It won't happen anytime soon. In fact, I've predicted based on certain linear models that I've been able to calculate, I've been able to predict that it could potentially reach that threshold, but it would reach that threshold during Christmas break. So we'd already be out. Fun stuff. Potentially, but those spikes don't happen for a few weeks after. For example, right now we're experiencing a spike because of Thanksgiving. Yeah. So Stafford is going to be actually this Wednesday. Stafford schools, not the high school, Stafford schools are going to be going fully virtual starting this Wednesday for the remainder of the calendar year, for the remainder of December. But then they go back January 4th, just like we do. My son goes to LBI schools. And my son going to LBI schools, they actually are going to be going virtual next week and the week after Christmas break. So that's kind of cool. Whatever. Who knows what the heck is going to happen. But anyway, here's my plan. First and foremost, I've gone through the majors that you guys did online. If you haven't, or if you're like, oh crap, I forgot to do that, despite the fact that Mr. Markey had us start them in class. I'm pausing there for dramatic effect. But if you didn't do that, you need to get on that. It's late now. But I've gone through the ones I've been able to, I had to go through them with like a little bit of a fine-tooth comb because Edge Elastic wasn't grading some of the questions exactly the way that I wanted them to. So I had to go through them and manually change them. Not to mention, I did have to manually grade one of your responses in regards to end behavior. Anyway, but yeah, make sure you're jumping on that because guess what the end of this week is? Progress reports. Yeah, fun stuff. Progress reports at the end of this week. Get your stuff in. Next, I have you Tuesday of next week. Guess what we're doing Tuesday of next week? No. Benchmarks. I know. I'm so excited too. For those of you online, you can't see it, but everyone stood up and cheered when I said benchmarks. It was so great. Huh? That's not up to me. That's not up to me whatsoever. It's not my job to say, hey, Lincoln, did you pick the right one? Hey, supervisor, did you pick the right one? Because I did that last time and I got crap for it. Yeah. Yeah, we all, a few of us got crap for it.
You know what? I'll stick up for you. And I'll go to the office and I'll say, make sure this is the right one.
It's not going to do anything. Don't use bad words. I'm live. Oh, gosh. Foul language. Anyway, as for today, I want to introduce the next chapter. I want to introduce the next chapter with some information that you have been exposed to, no pun intended, but have been exposed to back in Algebra 1. Possibly a little bit in geometry, but mainly Algebra 1. I only want to do the information that I want to give you for roughly half the class period. And then I have a quizzes lined up to kind of do an immediate feedback of, okay, what do we remember? What do we know? Et cetera, et cetera, et cetera. I want to be able to jump on this information. So if you would, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Last year, my wife got my family involved in a gingerbread house making competition. In Stafford Township had this competition where you could submit a gingerbread house, and they had like different categories that you could participate in, especially if like you were like a professional and junk like that. Like if you're a professional baker, then what? Like that's not cool. So this is the one. This is the gingerbread house that we made last year. And it's really cool because my son, he was 5 at the time. He's 6 now. My son designed this on paper. He drew this out on paper. And then my wife basically, okay, I'm going to have to bake this. I figured out all the math in terms of what size things needed to be and the angles and things of that nature. And then my wife baked the gingerbread from scratch. My son helped. You can see pretty much where he helped design it. But because of the just the family essence of being able to put this thing together, we did win last year. And I was so excited. Like we won. We took home a trophy. It's sitting in our kitchen. My son this year has designed another one, which I'm so excited for. But my kitchen is filled with gingerbread pieces now. Gosh. This year he designed the building to look like a Pokemon Center. So for those of you that are familiar with Pokemon, no one is. Great. Nerds. Anyway, back to this. But my whole kitchen is filled with gingerbread pieces. I'm a little peeved, but what can you do? Zoom back out. Well, we're going to win again. We will. None of you can stop us because you don't live in Stafford. Anyway, let's call this Intro to Chapter 6. Today is the 14th. We're getting there. We're 3.5 months into the school year. 3.5 months into the school year. You were saying? Yeah. 35% of the way through the school year so far. Hold on.
Mr. Junker, please come to the main office. Mr. Junker, please come to the main office.
35% of the way through the school year. At the end of this week, you'll be at 37.5%. I know, right? But yeah, it's just like that. Nuts. Anyway, back to this. I'm also going to call this, besides Intro to Chapter 6, I'm going to call this Exponents and Function Operations. I don't plan on getting to the function operations today, but it depends on how swiftly I can get through this information and whether or not Google is going to shut down again. That's fun. I've actually thought to myself this morning, I'm like, oh man, I can't live stream on YouTube because YouTube is connected to Google. Oh man, what am I going to do? Oh, well, I guess I'll have to do a Google Meet. And that's when I laughed at myself. Okay, fine. None of you find that interesting. Jerks.
I feel like you're extremely intelligent and I was an extremely unintelligent thought.
That was the gist of the joke. Thank you for explaining it.
I understand. That's where you're smart.
You want a better joke? Okay, ready? 2 peanuts are walking through the park. One of them was assaulted. There he is. Let's go. What is wrong with me? Exponent properties. Now, there are various exponent properties that you have been taught in the past that I need to remind you of. And what I'm going to do is I'm actually going to split my paper, where on the left side, I am going to give you the actual property. And on the right side, I am going to give you an example exemplifying that property. So, first property I got here, something very basic. A to the M times A to the N. And again, this is something that you have done in the past, but it's been a minute since you have seen or even cared to think about this information. And that's fine. The example, the actual physical example I can give you is something like x squared times x cubed. What do you think we should do? Or what do you want to do with this problem in order to simplify it? What do you vaguely remember in the past from your 2 years ago of Algebra 1? And I think about, well, I make you think about Algebra 1. I might be bringing up some painful memories. What do you want to do? Take a wild guess. What do you think I should do with these exponents? I hear crickets. I hear legit crickets. Well, how about this? If I have an x squared, how many x's are being multiplied together? Yeah. And if I have an x cubed? Okay. How many total x's are being multiplied together? We did it. This really should be x to the 5th. The rationale behind this is that if you are multiplying common bases, multiplying, then you are to add those exponents together. You are to add those exponents together. Fantastic. They have to be the same base. If they are not the same base, then you cannot do this. Then I have the following property. Now, pretty much people are able to kind of figure out the second property based on what the first property is doing. I'll separate these. There we go. Something like y to the 4th over y. And if I word it like this, then mostly everyone kind of gets it. Hey, guys, if I multiply common bases together and I have to add the exponents, what do you think is going to happen if I have to divide common bases? Yay! We did it! High fives all around at a safe distance. It's falling. Yes, you have to subtract. You have to subtract. Which is nice. Now, the way that this property works here in the example, this is actually y to the 1st power, which is why that when you subtract them, it becomes y cubed. There's a common mistake, and I'm going to be pointing out these common mistakes to you as we move forward, but I am going to be pointing out a lot of these, hopefully to kind of, again, exemplify the fact that I don't want you to make these same mistakes. I don't want you to. Anyway, if I have y cubed over a y, the general idea that you can hopefully visibly see is the fact that these two y's, yes, cancel each other out, leaving you, oh, it was a y to the 4th, my bad. There we go. It was a y to the 4th. But same thing applies. It leaves you with y cubed on the top of the fraction and just a 1 on the bottom. Oh no, it's falling. The most common mistake that I see in Algebra 2 is when I very quickly ask people, hey, what's x times x? And if you're just answering without thinking, I get one of two answers. I either get x squared or I get 2x. Which one is it supposed to be? What is x times x? Okay. What's the rationale for making it x squared? Hold on 1 second.
Excuse the interruption. Stephen Gonzalez, please report to the main lobby. You're being signed out.
You say x squared. I agree. What's the rationale using that property? X to the 1st, x to the 1st. Yeah, I agree wholeheartedly. But a lot of people say 2x. But that's not 2x. X plus x is 2x. I just need you to see the difference between them. Here's something that I constantly see. Check this out. just for the sake of argument, I just need you to see this. Here's something that I constantly see, a common mistake. I ask people, hey guys, what's x squared plus x squared? And the common answer, the common mistake that I get back is, okay, 2x to the fourth. And I say, no, it is not 2x to the fourth. What should this answer be? What is x squared plus x squared? I know, right? It's not 2x to the fourth. It is just 2x squared. Because the only time, and I need you to bore this into your brains, the only time that you change the exponent is if you are multiplying or dividing. That is the only time that you're going to change an exponent. If you're multiplying or dividing, here you are adding. Thus, the exponent stays the same. Again, these are very common mistakes. And the reason why I am drilling these down is because of what this chapter has in store for you. This brand new chapter has a ton of stuff in store for you. Oh no. Let's see what we got on the next page. Next property that I'm going to do, I'm going to have to, again, split my page a little. Here's the example. What do you kind of want to do with that exponent? What do you kind of want to do with that exponent? With that exponent of m, or in this example, the exponent of 2. Yeah, I want to distribute it. Are we allowed to? I see several people either gently nodding yes or nodding no. That's what I see right now behind your plexiglass shields. The answer is yes. Yes, you can. There's a reason. There's a reason why, but let's just write this down for now. Yes, you are allowed to distribute the exponent here. Yes. And in this case, for the example, hold on.
Mr. Junker, please call the main office. Mr. Junker, please call the main office.
In this example, I'm going to get 9x squared. Because yes, you have to distribute it not just to the x, but also to the 3. The division example is exactly the same. I just want you to see it and have it written down, of course. But the division example is almost exactly the same. Something like y over 2 cubed is y cubed over 8. Because it would be y to the 3rd power, 2 to the 3rd power. Yes, you are allowed to distribute the exponent in these cases. Let me split this again. What about here? What about here? X plus 4 squared. I have seen so many people take something like x plus 4 parentheses squared and completely screw it up. I don't want you to make that same mistake. I have seen so many people look at that problem and say to me, okay, Mr. Markey, it's x squared plus 16. No, it is not. This is not x squared plus 16. What the heck am I supposed to do then? What are you supposed to do here? Oh, we'll talk about that in one moment. Let me write down some additional information for you before I actually do this. First of all, parentheses a plus b parentheses to the m power I'm putting this in all caps just because I need you to see this. Not allowed to distribute exponent. Not allowed to distribute exponent. This is a no with addition, subtraction. It is a yes with multiplication, division. This is the big distinguishing factor between whether or not you are allowed to distribute an exponent. Yes, if there's multiplication, division separating the terms, as we saw in these two examples up here. It is a no for addition, subtraction. You are not allowed to distribute it. Let me give you an example. Give me two single-digit numbers. Any two single-digit numbers, doesn't matter. 9 and 6? Cool. What is the value of that expression? What should be the value of that expression? You can do it in your heads. What do I do first? How do I evaluate something like this? I add first. I go what? 15. What's 15 squared? You don't have to remember. You got to memorize 15 squared. It is 225. 225. That's what it is. That's what it should be. That's absolutely what that value is. 225. There's no changing it. There's absolutely no changing it. It's 225. That's the correct answer. But if you made this illegal move, if you made this illegal move, a move that you are not allowed to make, you go 117. Should be 225. And it is 225. This is wrong. This is illegal. This is an illegal mathematical move. You're not allowed to do that. That is a sick bird. Sick bird. Sound out the word illegal. Say the word illegal, but say it like slower.
Illegal.
There you go, sick bird. Man, I'm on fire today. Here's what we actually should do here. What we actually should do is multiply out x plus 4 times x plus 4. We do not distribute the exponent. We're not allowed to. You should actually multiply out x plus 4 times x plus 4 if you're squaring something, which in the end gets you x squared plus 8x plus 16. If you don't do that correctly, everything is going to fall apart. Okay. I'm going to try something here. I have a few more properties that I want to show you. Actually, you know what? Let me give you those properties first, and then I'm going to try something. Let me give you these properties first, and then I'm going to try something. 3. And then I'm going to try something to kind of exemplify them. What if I said 14? Okay. Power of a power. What do you kind of want to do? What do you feel like you should do in this scenario with a power to a power? Based on everything you've done, you might be able to logically guess it out. my side. No one wants to take a guess. How about this? Ooh, what'd you do? Yeah, and you're correct. You multiply those exponents. Power of a power. Yes. Multiply those exponents together. Yeah. How about this? A to the 0 power. Somebody give me a two-digit number. Two-digit number. Doesn't matter what it is. 13. 13 to the 0 power. What? Yes. It's a 1. They're both 1. It doesn't matter. You could have given me any number in the world. It does not matter.
267.
It doesn't matter. Watch. Hold on.
1. Everything's 1.
There's one exception. 0. I'll show you. Watch. There's one exception. You said 267?
Yeah.
To the 0 power. Look at that. Look up there. Watch this. 13 to the 0 power. 1 to the 0 power. Watch this. 0.1 to the 0 power. It doesn't matter. There's one exception.
Can you explain why?
Yes, I can. That's the thing that I wanted to try in a few moments.
Okay.
But there's a very distinct reason why. And I guarantee you, when you first learned this in Algebra 1, I guarantee you that when you first learned this in Algebra 1, anything raised to the 0 power, they just said, it's equal to 1. But why? And I guarantee you most of your teachers didn't explain it. Am I right? Yeah. I'm going to explain it to you. Sick bird. Assaulted. Anyway. 0 to the 0, by the way. 0 to the 0. Boom. Can't do it. That's the one exception. That's like dividing by 0.
So it's just not a thing.
Well, it's undefined. It's like if you did 2 divided by 0, what do you put as an answer? You can't do it. It's undefined. Yeah. The only exception is that the base cannot equal 0. That is the only exception. Now, like I said, there's one more property that I want to show you, and then I'm going to explain to you why that is. One more property that I got to show you, and it has to do with negative exponents. Negative exponents. Now, I'm going to say one word to you in regards to negative exponents. One word. Reciprocal. What the heck is a reciprocal? Flip what? Like, for example, if I have the number 4, what's the reciprocal of 4? 1 over 4. Yeah. I agree with you where you flip it. Yeah, but if, what's the reciprocal of 2/3? Exactly. You just flip it. And when you flip it, the exponent turns positive. The exponent turns positive.
It's a magic line.
Kind of. It's a magical thing. But now let me explain to you why that is. Check this out. Look at my calculator. Remember I said 4. Let's just say it was 4 to the negative first power. I said reciprocal, right? Whenever people see that, 4 to the negative 1 power, you know what they usually say to me? They say -4. And I say, nope, it is not -4. Not. If you flipped that 4, what would it become? What decimal? Chapow. Yeah. Check this out. 4 to the negative 2 power. You flip it. That 4 becomes a 1 over 4. It becomes a 1 over 4, but what happens to that negative 2? Yeah, so what's 1 over 4 squared? Huh? 1 over 16. Yeah. Ooh, patterns. I love patterns. You ready for this? This is what I wanted to try. This is the last thing I want to do before that quizzes. The last thing I want to do before this quiz. Oh, I didn't have one for that. This is the example. The thing I wanted to show you. Sure, if you want to. But the example that I wanted to show you was this. I know. Actually, you know what? No, I don't want to do 4. I'm going to use a different example. Hold on. Oh, that was almost really good. That almost made it, right? That like curved in midair. I'm going to do it with 3. 3 cubed is 27.
What's your favorite number?
Huh?
What's your favorite number?
Oh.
Single digit.
Oh.
You're supposed to have one.
No. Ladies and gentlemen, notice for a second in my notes. Notice that I am leaving a blank there. Oh, God.
It's a super simple. What should I title this?
Oh, the title that I gave it over here. It was exponent and function properties.
Yes, but you're showing us a longer example of one.
I know.
So what should I name it?
Surprise.
Oh my gosh, Mr. Monty. I'm actually gonna name it that.
Good. Watch this. I'm about to blow your minds open. I'm about to blow your minds open. Check this junk out. 3 cubed is 27 because 3 times 3 times 3. Can we agree on that? Cool. 3 squared is 9. I know we agree on that. 3 to the first power is 3. That's just common sense. I left a blank here. I'll come back to that blank in a minute. But now I come to 3 to the 0 power. According to that property, what is 3 to the 0 power? It should be, and it is. But watch this. You ready for the explanation? You got to look. You see the exponents. 3, 2, 1. Logically, what's the next exponent? 0. Yes. Look at what they're equal to. 27, 9, 3. What's happening? What's happening to them? Dividing by 3. 27 divided by 3. 9 divided by 3. Logically, the next calculation should be what? Well, what's the fraction? 27 divided by 3. 9 divided by 3. 3 divided by 3. It's a 1. It works for all of them. It works for all of them, except for 0. Because you can't divide by 0. You can't divide by 0. Then, logically, what's the next exponent after 0? -1. And I have taught you that when you take a negative exponent, what word must you think of? Reciprocal. Now watch this. You'll see. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Logically, what's the next calculation? Say again? 1/3. 1 divided by 3. That's what negative exponents do. It is a logical progression. And then when I get 3 to the -2nd power, 3 to the -2nd power, well, Mr. Markey, the property you told us said take the reciprocal of the base. Okay. You take the reciprocal of the base. It becomes 1/3. But then what happens to the exponent? What happens to the exponent? It becomes positive. So it's really 1/3 squared, which is what? 1/9.
And it just goes up, and then it's opposite. Beautiful.
Yeah. And then it keeps going. Then 3 to the -3 would be 1/27. And it just keeps going and going and going. It's insane. So I left a blank for the following reason. What's halfway between 0 and 1? 1/2. 3 to the 1/2 power. Any guesses? What'd you say? What's 3 to the 1/2 power? You know what a lot of people tell me? They tell me 1.5. It's wrong. That's wrong. This is introducing what we're doing in this chapter. Watch this. Nope. 3 to the 1/2 power is this decimal. Why? Why is it that decimal? What is it actually doing? Oh, goodness gracious. 3 to the 1/2 power is that decimal. I'm going to zoom back out and write that decimal. And then I'll come back into the calculator. 3 to the 1/2 power is actually 1.732 ... It keeps going forever. What the heck is it?
That looks like the beginning of somebody's phone number.
Kind of.
732.
That's just a coincidence. You ready for this?
No, not yet.
3 to the 1/2 power, what is it actually doing? I mean, all the other stuff kind of made sense. 3 cubed is 3 times 3 times 3. Yeah, negative exponents, that makes sense. Raising to the 0 power, I guess that logically makes sense. 3 to the 1/2 power. All right, time to blow your minds. You ready? That's what it is. That is legitimately what it is. When you raise anything to the 1/2 power, you are legitimately just taking a square root. That's what it is. To what? I know, it is. Check this out, right? You ready for this? You ready for this? You ready? You ready for this?
Wait, so when you raise anything to the 1/2 power, it's just
Square root. Yes. Now, I want to be very clear about something. Look what I just wrote on the board, or look what I just typed on the board. And look what I just typed on the board. I've said this since September. Parentheses will save your life. Parentheses will save your life. You need parentheses around that exponent. Or you could legitimately just type it in like this with the decimal. And there it is. Square root of 9. Boom, there it is. Who's in trouble? Mortgage room. Hey. Correct. Yes. Yeah. Yeah, it depends. It's usually like somewhere close to 10-ish, give or take. Yeah. Okay, bye. Weird. Anyway, yeah, that's what this thing does. This is what we're going to be getting into. It's going to be amazing. It's going to be absolutely amazing. So, with the remainder of the time that we have, what I would like to do is I would like to knock out a very brief quizzes on the stuff that we just learned. You okay?
yeah, I'm just so excited.
Good.
The third property, can you put the notes back up?
The third property, was it this one? You sure?
Yeah, I'm good.
Tell you what, I'm just going to leave it up here. I'm going to freeze the screen so I can change stuff over. I'll leave it up here like it's no big deal. Freeze. Boom. Come on, you. Boom. There it is. So, for those of you that are online, for those of you that are here, I'm going to need those Chromebooks out and open.
The Chromie. You guys are not very talkative today.
Unfreeze.
Are you guys ready for this business? Oh, I was born ready.
Check this. 222-146. Boom. 222-146. Put that into the chat just in case they can't see it. 222-146. Wrote that at the top of the board just so those people in the chat can see it. For those of you in the chat, the code is typed into the chat and at the top of the board for you to join. I know. I never doubted that. Or denied that, I should say. Yes. All right, you get logged in first. It doesn't say you are. Question? Yeah.
You're extremely intelligent.
I know I've read a lot.
Okay. Anyway, let me finish my question before you interrupt.
All right.
You're extremely intelligent. What made you want to be a teacher?
I like to collect the tears of students to keep me young.
No, I'm being serious. You're extremely intelligent.
I'll tell you this is a true story. You ready? When I was in elementary school, probably like second grade or so, we had to figure out what did we want to be when we grew up, right? And I wrote down that I wanted to be a stand-up comedian. I don't know why. My parents had probably. I'm the youngest of 4 kids. So I guess my idea is like, I'm the youngest of 4 kids. I like making people laugh. I like people. I like entertaining. And when I was in high school, I really was good at math without trying. So I decided I was going to put the two of them together. And I was going to be a math teacher. And then it wasn't until I actually began working with like younger kids and learning how to be a teacher and learning the details of math that I'm like, oh, wow, I really love math. Oh, wow, I really like teaching. This is cool. Let's keep doing this. Not to mention, like, I get to come in here every day. I get to teach something that I love. I get to act a fool. I get to tell peanut jokes. And I get paid for it. Like, I'm sorry, jackpot? I'm just saying. Anywho's, it's probably why I married a teacher. My wife's a kindergarten teacher. So, give me that. Give me that.
Sometimes the teacher blocks the things you say out.
Oh, yeah, tons.
The teacher mode, so she blocks it out.
Oh, she ignores me a lot. No, she doesn't. Come on! Anyway, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we had way more in the chat, though. For those of you in the chat, I mean, hey, I typed the code into the chat. You guys got to get on this. We're going to try this thing out. Let's get going. Once I click start, boom, the number will be at the top. There it is. You can still join even if the thing has started. You can still join. Get that thing in there. Yeah. Woo! Oh, yeah, you can totally use your notes. No problem. Yeah, use it. Oh, come on, I need to log in. Come on. You guys are responsible for your own stuff. Come on. Woo! Oh, I got it. Even if the bar runs out on the problem, it doesn't go to the next one, just so you know. So you haven't missed anything. Bum, 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 bum. no. Woo! Loud noises. I'll have you guys know so far you're doing a lot better than my other third period class. My other third period class averaged a 68%. So one could say that you wrecked them. Huh? Yeah. All right. I want to go over just a couple of questions before we wrap up here today. So I am going to end it here. And I want to talk about some of the red questions that you guys had. Let's see. Questions. You only had 2 of them. 16 and 19. Yes. This one. Number 16. Very interesting question. Simply because they had the same issue that you guys had. We just went over this whole deal about how when you raise something to the 0 power, you get a 1. But I need you to see this very clearly. -4x to the 0 power. I'm sorry. First of all, do you see any parentheses on there? Nope. There are no parentheses. I'm sorry. What's the exponent on the -4? It's a 1. The exponent on the -4 is a 1. Meaning, the x becomes a 1, and the -4 stays by itself. Yeah. Oh no, sadness. I know that's a fun one just because a lot of people end up tripping up on that. Whatever the exponent's on, as long as that base is not a 0. And then number 19, 9/27. 9/27, well, those aren't exponents. That reduces to a 1/3. And then x to the 7th, x to the 3rd, this becomes a 1/3 x to the 4th, which unfortunately none of them look exactly like that. But in reality, this is really x to the 4th over 3, or 1x to the 4th over 3. That's why it's got to be that one. Oh, that's a fun problem. These things keep falling on you guys. Go ahead. Oh, no, you didn't have a question?
Oh, no, sorry.
Cool. So here's what's going to happen. On Wednesday, I am going to continue with these lessons and getting into the concept of square roots. We will talk about the graphs of square roots. We will eventually get into solving square root functions. Not just square root functions, but multiple root functions, cubed root, 4th root, 5th root functions. It's going to be amazing. This whole chapter is about functions with fractional exponents. Now I have a question. Here's the beauty and the terribleness that is the benchmark, because you guys are taking that on Tuesday of next week, right? The beauty and terribleness of the benchmark is typically they're like, okay, teachers, you're going to give these benchmarks and we want to see progress. We want to see growth. We want to see them from the beginning of the year to the end of the year with their scores going up. Okay, so what does that mean? Well, we're going to give them a benchmark on stuff that they don't know how to do. Okay, and then throughout the entire school year, they're going to learn that stuff, so logically, they'll score better over time. Welcome to the world. 22nd. Yeah. Now, again, to be very clear about the benchmark, it doesn't count against your grade, but whatever you get on the benchmark is inputted into Genesis, but it counts as like 0%. You know what I'm saying? Not exactly. I don't really care what it does as to me as a teacher. It really reflects more poorly upon my supervisor for not getting scores up. Yeah. Me, I don't care. But I mean, I want to see you guys do as good as you can. But like, if you completely bomb it, I'm gonna be sad. But like, will it get me fired? I don't know. Let's see what happens. Yeah, I don't even know. Anyway, we got about a minute and a half before the end of the class period. I'm gonna sign off because I got to get a bunch of stuff together so I can get myself down to study hall. But I'm gonna sign off now. Goodbye to everyone. Enjoy the jokes. Woo!